Right. So the topic for today is rank of transformation semigroups, meaning that we want to see how many things you need to generate, how many elements you need to generate an entire semigroup, where the semigroups of interest for us will be transformation semigroups which are sub-semigroups of the semigroup of all functions from one set to the other set. We'll explain these things and some examples before actually you know going into the route of computing the rank. Okay, but this will be to start with an application of the theory of um, to be precise, the theory of the structure theory of simple semigroups. Okay, so that's the topic for today. Now, this presentation would be split into two parts. Okay, as you can understand, part one. In part one, we'll develop the necessary theory, the concrete realization, especially means the Riesz matrix theorem, basis theorem for simple and actually for completely simple semigroups. Okay, which of course we'll define. um, yeah, understanding the part two, we'll try to understand the nature of the semigroups that we are looking at, meaning that the Green's relations of these semigroup of all functions, semigroup of non-injective functions, and so on. The Green's relations is what will be needed there, and yeah, and then we'll just apply the theory to find the rank. Now, what are the features? The features of the part one will be just classical algebraic theory, okay? And the part two will be combinatorial, because in part two, when we have the representation theorems from part one, then we'll have these matrices coming in, okay, 0, 1 matrices, and so we'll be doing some combinatorial analysis of these. And also, since we are trying to generate finding generators for collection of functions, we'll have to see how to factorize functions and so on. Factorizing meaning in terms of composition, factorization, of course, using directed graphs. Basically, I should say just a generalization of cycle decomposition methods in group theory. Okay, so yeah, part one. We'll see in the next video.